Hey guys, Mr. Riz here. So I'm going to help you guys with the second day of the 118 activity. We're going to do part 2 and part 3. Both of these will be submittable things, as you will see. So let's start with part 2 here. So now you create a more practical program using the My Courses list and the grading algorithm. Okay, so what we did before. You will start with a small code segment and add to it so that the user can enter grade for a variety of courses. So we could go ahead, but what we're going to do is we'll submit this once we get through part 18, or part 14. All right, so right now we have My Courses English, Math, CS, and check grades equals true. So while check grades. So we could make this while check grades equal true. But if check grades is true, that's a Boolean value that should work. I'm assuming it might be messing with Ripple here, but we'll change it if we need to. So to help you plan your program, you can express what you want to do using pseudocode. Pseudocode is a representation of what a program does or what you want it to do. So written in a way that most people can understand. For example, you will create the code to make the grades perform as the following. So for each of the courses you are taking, we're going to enter a point count and display the corresponding grade based on that point count. So if you want to redo your grades, we'll start over. Otherwise, the program ends. Okay. So let's see this. Right now we have some code here. We have print. It makes a blank line and before enter your points for your course. All right. And then A equals input points. Okay. Redo. Want to redo these grades. So what we have here is we're going to test the code that will produce grade for once, confirming that all these parts. So we have kind of the code here mixed together and we got to figure out what we want to do. So let's start out with this for each course we're taking in. So if we go back to this one, while test grades are true, we'll put a for statement for every course in My Courses. Colon. So just kind of using these here. So the next thing we want to do is enter a point count and display the corresponding letter grade on that point count. So let's see which one does that. This one checks grades clearly. This is the redo, and this, okay, I guess we'll probably want to use this one. All right, print blank line and for every point. So we'll put that inside of this one. So print, just giving us a space here, and then we'll have another print. Enter your points for plus course. Enter your points for space plus course. So we're concatenating string here. And then what they have there, A equals input integer, or A equals integer of the input of points. And then they put like a little. I think I deleted something. Okay, so I think that'll be next. Next, if we want to redo the grades, start over. Okay, so maybe after this for loop is ending, once we enter in all our grades in our course, we'll put a if statement here, and this would be the redo. Redo equals, all right, input, do you want to redo the grades, yes or no? All right. All right, then if redo equal y, check grades equal true. All right, so make sure I'm lining this up here. Probably could open this up in a new, but so if redo equal y, check grades equals true. So else check grades equals false. So we'll change it to false. All right, and then what do we want to do? Oh, I guess I see a mistake here. That should be the program end. So what I also didn't do is to check to see if the letter grades were there. Okay, so I need to do that after we ask for them a point. So we'll do that nested inside of there. So we'll do all this if, and we'll go in the correct order here. If A is greater than or equal to 90, elif A is greater than or equal to 80, B, is that how it all goes? Elifs, yeah. Probably can even copy this and make my life easier. Control C, Control V. Nope, that's not working because it tapped. Now we'll change that to 70 to C. All right, tap back, paste that, elif 60 for a D, and then don't need to do another elif. I can just do an else. Print. All righty. So let's run through this code and see if this works out right. So enter your points for English. I can say I got an A in English. Trace back. All right. Oh, there seems to be an error here. Oh, I didn't enter points. I entered a value. Enter points for English. Let's say I got a 92%. That's an A. Enter point for math. I'll say I got a 65. D. Computer science. Let's say I got a 100%, but I just type in 10. That's an F. Do I want to redo? Yes. English 92. Math. I have an 85, which is a B, and computer science. I have a 100%. Do you want to read your grades? No. There we go. We're done. Okay. So once you got it working, you can test it out. It does everything there. Go ahead and submit that. We're going to move on to part 3 here. All right. So part 3, we're going to get the turtles to stop. All right. You will apply knowledge of conditionals and iterations to the turtle program. You've modified your code for transversing turtles from activity 116 so that the two list turtles, one that places turtle on the left side of the screen, one that places turtles on the top part of the screen. Copy and paste this code. Okay, so it's already here for you guys. We're going to run this here. Now, I'm going to recommend opening this up here, and we are going to fork this. All right, so we got a big activity here. Let's split screen the assignment and our code. In fact, if I can probably make our code a little bit longer, more organized here, we'll do that. So remember to fork it here. You guys probably don't need to, but I have to because I'm using the master copy. Okay, so let's run this to see what happens. We run this. All right, and we get a couple arrows and a couple turtles all going into there. Okay. So let's review the code so that you understand how the turtle objects are created and placed on the screen. Add comments at blank lines in the loop explaining what the code is doing. If necessary, run the code in the VO. I like to run it before I look at the code sometimes. Okay, so we import the turtle. We have a list of horizontal turtles and vertical turtles. And so those are two empty lists. And then we have turtle shapes, which are set up like so. And then we have horizontal colors. So, and T-lock equals 50. I wonder what that does. All right, so for every S in turtle shapes, HT equals turtle.turtle. So HT.shapes S, horizontal turtle and HT dot So new color equals horizontal T. So what it looks like here, we're making the horizontal turtle. So maybe I'll put a common code. Make a horizontal turtle. Now we probably could go through and talk about, okay, we get the new color is up here, which is popped. So it's the last one from a horizontal color. So the first one was gold. Was it gold? Yeah. And then we set its heading to 0. Then we make a vertical turtle. Same thing that's going on here. We add it to the vertical turtle list. We pick its pen up, and then we make the vertical color pop. So we can see brown, which is this one here. So are these brown, indigo, salmon, lime? Okay, yeah, these ones up here are vertical. So the ones up at the top That's kind of weird. I would call these maybe because of the direction they move. What will happen next? And then we make the T log equal plus or minus 50. So it looks like that's going to be the distance between them. Yeah, because each one goes to negative. Okay. All right, now your goal is to move the turtle objects across the screen horizontally or down the screen vertically, and add them, stop them if they collide. So read through the next 5 steps. Write some of these pseudocode and explain how to accomplish them and begin your writing. So you will process all of the turtles inside these steps less than 50 loop. All right, so let's right here. That's what's going on first. Well, nested loops, each turtle object takes 50 steps either across the screen or down. Okay, so let's actually nest this out. Steps equals 0, while steps is less than 50, steps equals step plus 1. See if that does anything different to us. Probably won't. All right, while this is going, I'm going to read the next part. So to detect collisions, you need to know if a turtle's XY position on the screen. You will find the following methods useful. So we could have the X coordinate method. So an example would be like myturtle.xcoord. This will give the X coordinate, the current X coordinate of the turtle. Same thing with Y coordinate. All right, so when I blocked that out, that did nothing to the turtles here. So to detect collisions, you'll need to determine whether turtles get too close to each other. In a coordinate system of positive and negative values, you need to get the absolute value of the distance between the turtles. You can use a new method called ABS to calculate the distance between the X and Y coordinates. So for example, the statement ABS x2 minus x1 determines the distance a turtle's position, and ABS y2 minus y1 determines the distance between the turtle's y position. If the distance are too close, there is a collision. A good distance for turtles getting too close is about 20 pixels. So please note that the exact value vary depending on the specific turtle shape of the turtle. So you can ignore this. So if a collision does occur, stop moving the turtles that have collided. To do this, you can remove a collided turtle from its list. So recall the pop method from the last element in a list. Python provides another way to remove an item list. The remove method searches for the element in a list and removes it. You provide the element you want to be removed as a parameter. For example, if you have a turtle list, you can remove a turtle from the turtle list as removed.myturtle. Okay, so let's write the pseudocode and solution only use hint. So what we need to do is get these things moving, right? So while steps is less than 50, let's see if we can just get them to move first and think about how we're going to do that. Okay, so let's think. If we have a list of turtles, what we want to do in the horizontal and the vertical turtles is to move each one forward. So we can make it probably go by a step, but let's just do this like for every horizontal turtle in the horizontal turtle list, right? And then we'd also have to do this for every vertical turtle in the vertical turtle list, right? We would have to make the horizontal turtle go forward. And we'll say just, well, if we do steps, each step goes up by 1. So the first time we move 1 and then the next time we move 2. So maybe let's, we could just make a set amount here, or let's do something here. We could just make a step number like 3, make it go forward 3 spots, but that could change throughout. And we might want to change it. So I'm going to make another variable called distance here. I'm going to make it equal to 3 and then use it here. Now I'm doing this even though it's kind of longer is in case there's something I need to change later on. I can adjust just distance here. The value of it is adjusted up here, but the equation. So maybe horizontal turtle might move faster than the vertical ones. We're going to just test it out. Let's see, unindented error. What did I mess up here on line 45? For every HT in. Got a while loop here. All right, let me try to see my error here that I made up. Is it called? Yeah, it's saying unindented, does not mention any unindented letters. Okay. Just delete, maybe run, try that again. No, same thing. All right, let me try to figure out my mistake. Okay, this took me forever to figure out what was causing the error, and this will probably happen to you guys as well. So watching this, it says there's unindented, and if you look, everything's lined up. Well, one thing to notice here is that there's two different ways to, and you really have to zoom in to see, there's two different ways to do indentations. You can either use a tab or you can use a double space. So if you look here on line 44 in mine, it is a double space. You can see I have a space, then a number of space to get to the 4, but the steps is a single tab. And they are apparently not equal. So to make them equal, I'm going to go back on steps, line up, and press enter, and then go back here and press enter. So now everything is lined up. The code didn't change at all, but now it works. So let's see what this code does. So that was really frustrating. So hopefully we line them up, and now they're just going to move forward, and they're all going to move forward 50 times 3 pixels each. So it should go 150 pixels across the screen. So it seems like they're all kind of meeting up at the same spot. No graph is going quicker than the other. They're just moving. Like these ones are moving smaller incrementally, but the horizontal turtles move larger gaps. Okay. And they're just going to keep going. So next thing we got to do is program to see if there's a collision. Oh, there we go. I had to double check my work here. So how do we make a conditional? Well, let's make an if statement here. So if we go forward, so we want to make the collision occur if their distance between the two is less than like 20. So what do we want to what do we want to call this? I'm just trying to think of a name, like see what I used on my answer key before. Actually I have it, oh, pixel size. So yeah, let's do pixel size. Pixel size is equal to 20. This is going to be like our distance that we want to get them close. Now we can adjust that based on how close they are, but we got to get some statements here. So let's get some information here. And we'll make the values equal to each one. So we'll make like x chord equal to, oh wait, let's make sure we know how to go back and do this. So that's the x coordinate. Let's just call the xc equals ht dot x chord. We got to call these like different ones because we're going to have multiple, right? We're going to have one for the horizontal turtle. So htxc, the horizontal turtle's x coordinate is equal to ht dot x chord, and htyc is equal to ht dot y chord. So we're going to get the x and y values from both the horizontal and vertical turtle. Vertical turtle xc equals, so you probably can't see this on the screen here, equals bt dot x chord, and let's see, vtyc equals bt minus y chord. Okay, so we're just getting the values and we're applying those two here. So now we need to make like a conditional statement, like if there is ever a collision. So if the distance between the x and y values is like less than the pixel value, we'll go ahead and do that. So let's just make like, I don't know, maybe make another value. Now we already have distance. That's how far they move forward. Actually, you know what? I don't like that. Let's just call this length, because I'd rather use distance with the distance formula. Okay. So we could, nest this inside of conditional, but I'm kind of more like, let's focus on the distance form. So distance equals, alrighty, let's go through and check this out. So I can do like x2 minus x1 squared, and I need to do the absolute value of that. So, and then take the square root of all that. So let's just kind of start with the beginning here. I got htxc minus btxc. I need to take the absolute value of that. Probably don't even need to do that though if I'm going to square it, but I will do it anyways, times 2. So this is x2 minus x1 squared, and then plus, we got to do the same thing with the y's, right? So I'm just going to copy this one here, but we'll change those to y's, y2 minus y1 squared. And then we got to take the square root of all that. So the square root of all that would be raising it to the 1/2 power. So times 0.5. So there's the distance. All right. You know what we want to do here is just let's print the distance here. Let's put a tracer around in here to see if this is right. So print distance. I might get real crazy here. Oh, did I not use it? Did I spell it wrong? Yeah, I did. I spelled it wrong up here. Now I got to go through all that again. Coding, isn't it so much fun? So what I'm doing here is just going to make sure our distance works out correctly. Now I probably can just start adding here, like if distance is less than pixel size, then we're going to do something, right? But let's see if this first part works, and we'll see if the distances pop up. And we'll probably get a lot of them. Okay. So each time it's going through and calculating the distance between all these turtles, we see sometimes it does. I mean, I'd have to stop this. Let's see, there are times where it's less than 20. So far, probably will be only 3 times. Oh, there's 1 time. So, okay, we are getting times where values do happen. Another time. This big long list here. Every single step would require a print statement. I wish that was probably that 1 time right there. Okay, what did happen? So now we can start adding code to make it do something. So let's see if that distance is less than 20. Let's make that turtle stop, and let's have them change color. Well, let's see if we can make them change color. So let's make ht dot color. Let's make them gray. bt dot color. And then let's remove them from the list, right? So we'll make, we got to remove from the list, and we're going to do that. That's how we're going to make them stop moving, because once they're removed from the list is by using the remove. So we are going to do, let's see, let's talk about the horizontal list though. Horizontal turtles dot remove ht. We'll remove that horizontal turtle, and we'll make vertical turtles dot remove that vertical turtle. Okay, so let's run this and see what happens. Our goal is to, when these distances get close, the turtles will turn grayed, and then they will be removed from the list. So that means they should just stop moving, since only the turtles on the list are going to move. So the first collision should start up here. Okay, they turned gray and they stopped. About the next one, they turned gray and stop, gray and stop, gray and stop, gray and stop, gray and stop. Cool. There we go. We got it set up. So we had a couple errors there and we walked it through it, guys. But this was a long one. Hopefully you guys saw some things and learned some things. We're getting to the end of the unit here. So things are getting a little tough, but be all right. All right, guys, have a great day. See you next time.